Good morning, everyone. It is a pleasure to be here today to discuss the importance of green chemistry and sustainable synthesis in the development of sustainable chemical processes. Together we will explore how biocatalysts can help create processes that are safer, more efficient, and less harmful to the environment. Let's get started. Green chemistry and sustainable synthesis are the foundation for constructing a sustainable future. Applying these concepts, we can create chemical processes that are safer, more effective, and gentler on the environment. This presentation will cover how these principles can be used to generate a more sustainable future and the advantageous results it could bring to our planet. Green chemistry is an approach to chemical production and design that focuses on avoiding and lowering dangerous chemicals. It seeks to increase effectiveness and cut down energy utilization, favoring the utilization of renewable sources and preventing waste. Biocatalysts play a vital role in green chemistry, as they can be used as a substitute for conventional chemical catalysts to catalyze responses with more exactness and effectiveness, and bypassing the production of hazardous waste. Biomass is increasingly being utilized in sustainable synthesis, leveraging renewable resources over non-renewable in order to reduce waste production, increase efficiency, and reduce environmental damage. Sustainable synthesis offers an array of possibilities with a multitude of benefits. Green solvents provide a safer and more cleaner alternative to traditional solvents, offering a key to sustainable chemical processes. Renewable resources are among the sources for these solvents, with some modified from their traditional form to reduce their environmental impact, like acetone and methanol. Moreover, green solvents can be derived from natural resources, such as water and ethanol, making them crucial for developing sustainable chemical processes. Biocatalysts are an emerging class of catalysts that have enormous potential when it comes to sustainable chemical processes. Biocatalysts are an efficient and sustainable alternative to traditional catalysts because they are derived from natural sources, are more cost-effective, and can reduce the environmental impact of chemical processes. By using biocatalysts, we can reduce energy consumption and toxic waste, and maximize the efficiency of chemical processes. Furthermore, biocatalysts can be used to produce chemicals and materials with improved properties, such as increased reactivity and increased solubility. Biocatalysts are a powerful tool for developing more sustainable chemical processes. By using biocatalysts, we can create reactions that are more efficient and have a reduced environmental impact. Furthermore, biocatalysts can reduce energy consumption, toxic waste, and the amount of energy required to complete the reaction, resulting in the development of greener and more efficient chemical processes. In order to reduce waste production, green chemistry and sustainable synthesis offer an effective and efficient approach. By utilizing catalytic reactions, we can reduce the amount of byproducts generated, as well as design processes that utilize all reactants. An example of this is the production of biodiesel, where the glycerol byproduct can be used to create valuable chemicals such as propylene glycol or 1,3-propanediol. This not only helps to reduce waste, but also helps create a more sustainable and profitable process. Green chemistry and sustainable synthesis are essential for our world. As scientists and engineers, the choices we make can have a long-term effect on our environment and society. Applying green chemistry principles can help to decrease waste generation, make chemical processes more effective, and move towards a more sustainable future. We have an obligation to ensure future generations have an unpolluted world to inhabit. Incorporating green chemistry into our work can provide us with the means to accomplish this objective. Green chemistry is vital for the future of sustainable chemical production. Despite advances in the field, there are still many challenges to overcome before green chemistry principles can be fully adopted. The most pressing of these challenges is the need for a drastic shift in the way chemicals are produced. This involves making significant changes to established processes, which can be a difficult task. Additionally, stakeholders invested in current production methods may resist such changes. Another challenge lies in the need for new technologies and materials that are compatible with green chemistry principles. This requires extensive research and development to develop and bring these materials to market. With commitment and dedication, these challenges can be overcome to create a more sustainable future. The implementation of green chemistry principles in chemical processes is essential for sustainable growth. However, this process is not without challenges. One of the biggest challenges is the need to balance economic, environmental, and social factors. Companies may need to invest in new processes and equipment to reduce waste production, but this can be expensive and may not provide an immediate return on investment. To overcome this challenge, it is important to take a holistic approach to sustainability and consider the long-term benefits of green chemistry. Another challenge is the lack of awareness and education about green chemistry principles. Many chemists are still unfamiliar with green chemistry, and this lack of understanding can make it difficult to implement sustainable processes in the industry. To address this, we need to focus on developing educational materials and tools that raise awareness about green chemistry and its potential to benefit the environment. Green chemistry and sustainability are key elements for a more sustainable future. Applying green chemistry principles to the design of processes and products can minimize waste, reduce energy consumption, and create safer products for humans and the environment. For instance, more sustainable solvents can be developed thanks to green chemistry principles, being non-toxic and biodegradable. Additionally, catalysts can be designed to streamline reactions and require less energy, contributing to energy-efficient processes with less effect on the environment. We, as chemists, have a duty to devise methods that put as little strain on our environment as possible. Utilizing biocatalysts to establish long-lasting chemical procedures is one way to achieve this. Taking into consideration the whole life cycle of a product can help to make it more sustainable and reduce its environmental effect. By utilizing the right solutions, we can join forces and construct a brighter, more sustainable future. Green chemistry and sustainable synthesis have a range of advantages for both the environment and industry. These approaches, such as reducing waste output, creating more efficient catalysts and opting for green solvents, allow chemical processes to become more cost-effective and better for the environment. It is also essential to include green chemistry principles in teaching and training for the future generation of chemists to be mindful of sustainability in their work. This form of chemistry can even lead to the creation of safer chemical products, diminished use of hazardous chemicals, and amplified protection for workers and consumers from any potential harm. Green chemistry is a powerful tool to teach students and give them practical insights into how to address environmental issues in the future. Incorporating this into the curriculum and providing case studies can allow students to discover how green chemistry principles are applied in the real world. Armed with this knowledge, students can develop more sustainable chemical processes with less waste and impact on the environment. Chemistry has the potential to make a huge difference when it comes to sustainability. We see great promise in the development of more efficient and selective catalysts, renewable feedstocks, and new methods for recycling and repurposing waste materials. By finding ways to reuse materials, we can reduce the environmental impact of chemical processes and create a more circular economy. These paths forward represent a huge opportunity to create a more sustainable future for all of us. Gaining insight into green chemistry and its principles is important in order to create a more sustainable future. We explored how these principles can be applied to the design of sustainable chemical processes, as well as the need for green solvents, efficient catalysts, and waste reduction in order to make these processes successful. Challenges associated with implementation of green chemistry were also addressed, as were strategies to help overcome these obstacles. Moreover, the importance of incorporating green chemistry principles into educational and training programs was highlighted. Looking to the future, we discussed the potential of green chemistry to contribute to a more sustainable and environmentally friendly future. To sum up, green chemistry and sustainable synthesis are essential for achieving a sustainable future, and we thank you for your attention.